Okay, today we're going to learn about the commutative property of addition. This should be page number 10 in your interactive notebook. Our learning target today is to identify and apply the commutative property of addition. And the word commutative comes from the word commute, which means to move, right? When your parents commute to work, they move from your house to their job. So commute and move are two words that I want you to associate with each other. Real quickly, just what is a property? We're beginning to learn about these properties of expressions, and properties are the mathematical laws that our number system obeys. They're derived from logic, even though to most people these properties are intuitive. They're just common sense. Two words that we're going to focus heavily on when we define what these properties mean are term and factors. So what is an algebraic term? An algebraic term is either a single number, so an example would be like 5, or a variable like y, or a combination of factors. So a combination of factors could be something like 3xb, right? This is a combination of factors. And terms are separated by plus or minus. So here we have got our plus or minus signs. And I know that when I look at this expression, there's three terms because I can draw these dotted lines through the addition and the subtraction signs, right? And then I can go ahead and count how many terms there are. So here's one term, here's two terms, and here's three terms. So we've got three terms. Two of the terms are positive. We got a positive 5 and a plus y, so it's a positive y. And one of the terms is a negative because the minus makes it a negative term. So what is an algebraic factor? An algebraic factor are numbers or variables that are being multiplied. So a great example of that would be negative 3xb. This is an example of an algebraic factor. We have three factors being multiplied. We've got 1, negative 3 is being multiplied to x, and 2b. So we've got three things that are being multiplied here. So if we added, I don't know, let's just say, for example, 5v, right? In this example, we've got two factors. Okay, we've got two factors. In total, if we counted up the number of terms that this expression had, we would have two terms because here's the addition sign. We've got one factor, and we've got one term, and we've got two terms. And the first term has three factors. The second term only has two factors. So the examples of what terms and factors are. So the commutative property of addition, let's go ahead and formally define what this is. So the commutative property of addition, or in Schoology you can go ahead and abbreviate that property as just CPA, states that changing the order in which terms are added does not change the sum. So changing the order, or moving around the order, right? This word change means to move. In which terms, very, very important that we're moving terms, okay, not factors, terms are added, does not change the sum, or another word for sum could be outcome, right? And we can see this in the example here, this mathematical definition, a plus b. So when we add a to b, it's the exact same thing, or it's equal to adding b to a. It doesn't matter which order we add the two terms in, as long as we're adding them together and not changing their values. So if we put numbers in for a and b, we can choose numbers arbitrarily. So if we say that a is 17 and b is 2, right? What this property is saying is we can add 17 plus 2 in the opposite order. So we can say 2 plus 17 is the same exact thing. And when we simplify this, you can see that both expressions result in 19. We get 19 on both sides, and it wouldn't matter which numbers we plugged in for these variables, we would get the same exact number on both sides. We can change the order that terms are added. An example with a variable would be something like 3 plus 6x. So this commutative property is saying we can take these terms, and in this example we've got two terms, and we can change the order that they're being added. So we can just say 3 plus 6x is the same thing as 6x plus 3. We can switch this order around. And then one more example with more than just two terms would be something like if we had 5 plus 2x plus 3x squared. right? So if we wanted to change the order here, we can go ahead and do that very, very easily. We've got 3 terms. Then we can just commute this 3x squared to the front. We can commute this 5 to the back. And we can leave the 2x in the middle. And what the expression would look like is 3x squared plus 2x plus 5. Or we could commute it differently. We could say let's not commute the 3x squared all the way to the front. Let's just commute it to the middle. We could say that 5 plus 3x squared plus 2x is also the same thing. So the commutative property allows us to rearrange these terms. So the question now becomes, what about commuting subtraction? So what if we had something like 5 minus 2? Can we commute subtraction? And to that I would answer, yes, of course we could, because we can convert our subtraction back to addition. Remember, subtracting is the same thing as just adding a negative, so we can say that 5 minus 2 is the same thing as 5 plus a negative 2. And now that we've got our addition, we can go ahead and just commute this negative 2 in front of the 5. So we can say negative 2 plus 5 is the same exact thing as 5 minus 2, because in all 3 of these examples, they simplify to a positive 3. And if you don't believe me, go ahead and try them all out, right? So an example. So if we had an expression with a variable, so let's say we had 3x plus 2 minus x squared, and we wanted to commute this negative x squared or this minus x squared to the very front, right? We don't always have to write it as plus and negative. We could just now know that if I want to commute this term that has a subtraction sign in front of it, I've got to make sure that I include this subtraction sign with the term when I commute it. So I'm going to commute it to the front. I'm going to keep the subtraction sign. So what sign is going to go in front of the 3x now that it's not in the front? Well, if it was positive, then it's going to be a plus. So we can say that these expressions are the exact same as each other, right? So the signs of each term stayed the same. It was negative, still is, right? It was positive, still positive. It was positive, we'd write the plus. So let's go ahead and get into 2 examples today. Here's our first example, and this example is asking us to provide a justification for each expression. So while we're thinking about this, remember the word commute means to move the order of terms. And so in math, when you move things or when you simplify things, you have to give reasons or cite mathematical laws for why you're doing or what allows you to do what you're doing to the expression. So we have the expression negative 5x plus 4 minus 3y, and we go from this expression to the one that's below it, this expression negative 5x minus 3y plus 4. We have to give a reason for why we can move or change the expression. And the reason here is the commutative property of addition, because you can see we've got negative 5x plus 4 minus 3y. So we've got 3 terms. In the second expression, we also have 3 terms. But the order of those 3 terms has changed. The negative 5x stayed in the same exact location, but you can see here this minus 3y was commuted in front of this positive 4. Now you can see that this minus 3y is now in front of the positive 4. The signs of the terms did not change. The terms themselves, the factors within the terms did not change. Only the order did. So we can go ahead and say this is the commutative property of addition. Right? Now look at this next example. This next example is a little bit more challenging. You're probably looking at it and saying, okay, this one has 3 terms because you see addition and subtraction. But in fact, this example right here only has 2 terms. The reason why it only has 2 terms is, if you remember from how we defined what a term was, and I'll go back to it real quickly. A term is a combination of factors. Combination of factors are things that are being multiplied. And this factor, or this term right here, is a combination of factors. We've got the factor 3 being multiplied to the factor x minus 2. Even though there's a subtraction sign in here, the parentheses actually make this a factor. So we only have 2 terms. So you can see what they did was they took this factor plus 3 or positive 3 times x minus 2, and they commuted it in front of the negative 5, and they got this new expression. So we can go ahead and say that this was the commutative property of addition, right? And now they took this expression that they commuted the terms from, and they also commuted again, but this time they're not commuting the two main terms. What they did was, if you look at the terms inside the parentheses only, right, we've got x as one term and -2 or -2 is the second term. We've only got two terms inside this parentheses. What they did was they commuted the terms within inside the parentheses. They took this -2 and they commuted it in front of the positive x, and they got their new expression. So this is also an example of the commutative property of addition. This will be the last example for today. Whoops, wrong one. So we have our second example today. This example is asking us to select the following expressions that have been rewritten with the commutative property of addition, or CPA. So with these examples, right, it's going to give us this expression, and we've got to figure out which of the 5 expressions, and there could be more than one, match this given expression. So the first step is to identify the number of terms in the given expression. So you can see here we've got a subtraction sign, so we can go ahead and kind of identify that as a term. Then we've got an addition sign in here, and we know that there's going to be 2 terms here. But very important to note that this first term, 2y, has 2 factors, right? 2 times y. 2 is a factor, y is a factor. And this second term has 2 factors, a factor of -3 and a factor of -5x plus 17. And within this second factor, we have 2 more terms. So within the second factor, we have 2 more terms. So these are smaller terms within the second term. That kind of makes sense. So let's look at example number A. We've got 2y minus 3 times 17 minus 5x. So let's go ahead and separate the main terms, right? We've got this subtraction sign, and we've got this subtraction sign right here. So it looks like the first term, this 2y, has stayed the same. So far this is good. Our first term is good. And then our second term had 2 factors, right? It had a -3, which is good, and then it had a -5x plus 17. Well, it looks like the second factor has changed to a 17 minus 5x. So we've got to ask ourselves, did they commute these 2 terms inside the parentheses correctly? So if we were to commute this -5x, it would become subtraction. And it looks like it is subtraction. And it looks like the positive 17 is still a positive 17. So example number A, and I'm going to circle it with purple or black, is correct. This is an example of the commutative property performed correctly. Let's look at example number B. So here we have our subtraction sign, and then we've got an addition sign. So our first term right here has only 1 factor, just 3. Neither of these terms was only 1 factor. Both terms were 2 factors, so we already know that this is not an example of the commutative property of addition. You can see here that all they did was they switched the 3 and the -2y. They've changed the factors of the term. You can't change the factors of the term. You can just change the order of the term. So this is no good. Look at number C, letter C. 2y separated by subtraction, and then we've got this inside the parentheses separated by addition. So it looks like our first term has remained the same. 2y is still 2y. And then our second term, they've shifted some things around. This -3, the first factor is good, but the second factor in that second term has shifted from a -17 to a plus 5x. Well, this was a minus 5x or a -5x, and now it's a positive 5x. The commutative property does not let us change the signs or the values of terms, so this is not an example of the commutative property. Look at D. Right, you can see here that now the first term is -3 times -5x plus 17, and the second term is a positive 2y. So you can see here, this is an example because